Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concept of derivatives. So as per the problem, the profit function of a commodity is P at x equals x times e to the power negative 0.5 x squared, where x is greater than 0. Find the maximum value of the function if x is measured in hundreds of units and p is measured in thousands of dollars. So we have to find the maximum value for this profit function. So let's start by writing this profit function. Now the domain for this function is given as x is greater than 0. Now we have to find the maximum value for this function. So we have to find the derivative of this function and then set the derivative equal to 0 to find the x value at which the tangent is horizontal, because at the maximum value the tangent will be horizontal because it will be a peak in the graph of the function p at x. So let's start by finding the derivative of this function. Now this function is made up of two functions. So there is this polynomial function x and the exponential function e to the power negative 0.5 x squared. And these two functions are being multiplied, so we should use product rule to find the derivative of this function. So as per the product rule, so we start with the derivative of the first function, that is x, and the derivative of x is 1 times the second function plus the first function times the derivative of the second function. Now the second function is an exponential function with base e, so the derivative will be the e term itself times the derivative of its exponent, and the exponent is negative 0.5 x squared. Now in this exponent, negative 0.5 is the coefficient of the exponent, so it will stay as it is. And as per the power rule, the derivative of x squared is 2x. So this is the expression for the derivative of p at x. Now we can simplify this expression. So 1 times the e term will just be the e term. And in the second part, so negative 0.5 times 2x will just be negative 1x, and negative 1x times the x at the front will just be negative 1x squared or negative x squared times the e term. Now we can set the derivative equal to 0 so that we can find the value of x at which the tangent is horizontal. So we have to solve this equation. So for that we should factor this equation. We can do common factoring. We can factor out the e term. And we are left with, now we can solve this equation by analyzing the cases. So the first case is Now this is an exponential term and the variable x is in the exponent. So there is no x value that will make the left side equal to 0. So as a result, this case has no solution. Now we can analyze the second case. So we can subtract 1 from both sides to isolate x. So we get so now we can divide both sides by -1. So the negatives get cancelled out. So we get x squared equals 1, and now we can apply square root to both sides. So on the left side, the square root and the square get cancelled out, and we get x equals plus minus 1. Now the given domain is x is greater than 0. That means x equals -1 is an invalid solution. So the only valid solution here is x equals +1 because -1 is less than 0. So this is the x value at which the tangent is horizontal. Now we should check whether this x number represents a maximum point, and for that we can use the first derivative test. So we can use the number line method. So x equals 1 represent a critical number for this function. So we should check whether the function is increasing or decreasing on the left and the right side of this critical number to find whether this critical number represents a local maximum. So on the left side of 1 we can use the test value 0.9, and on the right side we can use the test value 1.1. So now we should sub in these test values in the expression for the first derivative and then check whether we get a positive or a negative value for the first derivative. So as per the first derivative test, so if the first derivative is greater than 0, that means the function is increasing in that interval, and if the first derivative is less than 0, that means the function is decreasing in that interval. So let's start with x equals 0.9. So we get e. So we sub in x as 0.9. Now we can evaluate this expression. So first we'll evaluate negative 0.5 times 0.9 square. So I got e to the power negative 0.405 and minus, and 0.9 square is equal to 0.81 times e to the power negative 0.405. Now we can evaluate the terms. So e to the power negative 0.405. So I got 0.667 minus the 0.81 times 0.7. Now we can evaluate this expression. So 0.667 minus 0.81 times 0.667. So I got 0.1263. So I got a positive value for the first derivative on the left side of x equals 1. So that means the function is increasing on the left side of x equals 1. Now we can find the value of the first derivative on the right side of x equals 1. So I'll sub in x as 1.1. Now we can simplify this expression. So first we can simplify the exponent. So negative 0.5 times 1.1 squared. So I got e exponent negative 0.605 minus 1.1 squared, which is equal to 1.21 times e to the power negative 0.605. So now we can just continue here. Now we can evaluate the e terms. So I got 0.56 minus, and now we can do the final calculation. 0.546 minus 1.21 times 0.546. So I got negative. So that means the first derivative is negative to the right side of x equals 1. That means the function is decreasing on the right side of x equals 1. So based on these results, we can conclude that x equals 1 represents local maximum because the function is increasing on its left side and decreasing on its right side. Now we have to find the maximum value of the function. So for that, we will sub in x as 1 in the given profit function. So we'll have to calculate p at 1. So 1. So this is the expression we get. Now we have to evaluate it. So 1 times e term will just be the e term. It will be e to the power 1 square is 1 times negative 0.5 is negative 0.5. And now we can evaluate it. So I got 0.607. Now as per the problem, P represents thousands of dollars. So therefore, the value of the maximum profit in dollars will be 0.607 times 1000, which is equal to approximately $607. So that means the maximum value of the profit is $607. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.